This is section 5.2. We're going to be talking about finding the 6 trigonometric ratios in a right triangle. So given a right triangle, we should be able to not only find the length of the missing side of the right triangle, we should be able to find all the ratios as well. So we need to take a right triangle and assign some values. In this case, we're going to keep it simple. Both of the legs have the same size, and we need to find the length of the missing side, so that would be side AB. And then once we find the length of the missing side, we're going to find the ratios based on this angle theta, which is the same as angle A. So in order to find the missing side AB, we use the Pythagorean theorem. So the missing side is the hypotenuse in this case, across from the right triangle. So that side squared is equal to the squares of the other two added together. 4 squared plus 4 squared. So c squared is equal to 16 plus 16. So c squared is equal to 32. C is equal to square root of 32. We can't leave it as a square root of 32. We have to simplify that. In this case, square root of 32 simplifies into 2 times 16. And the reason you use 16, or for any number that you get, you're looking for perfect squares that are factors of that number, so you could pull that number out. So the square root of 16 is 4, so that's the number we're going to pull outside the radical. And then we just simply write what's left over is the square root of 2. So the length of this side is 4, the square root of 2. Now we go to our ratios. And from section 1, you should have memorized by now sine, cosine, and tangent. So sine of this angle will be the opposite of the angle over the hypotenuse. So it'll be 4 over 4 square root of 2. But we must get the denominator free from any radicals, so they have to be removed. So we multiply it by the radical over the radical. And doing this, we'll just simply, let's write them together so you can see what's going on. That's just simply writing all the items together, and now we can start to simplify. Square root of 2 times square root of 2 is just simply the number itself, so it'll be the number 2. So we have 4 the square root of 2 over 8, because we have a 4 left over on the bottom. That's 4 times 2. And then we simplify the 4 over 8 into 1 over 2, the square root of 2. And so we leave out the 1, so the answer is square root of 2 over 2. So if sine of theta is square root of 2 over 2, cosine of theta is going to be the same thing, because it's the adjacent over the hypotenuse. In this case, it's 4 over 4 square root of 2. So we're going to get the same answer as sine, square root of 2 over 2. And then tangent would be opposite over adjacent. So that would be 4 over 4, and that simplifies into 1. So square root of 2 over 2 for the first two, and tangent equals 1. Now we can take those numbers, those values, and find cosecant, secant, and cotangent. So square root of 2 over 2, square root of 2 over 2, and 1. So cosecant is 1 over sine, so that's 1 over square root of 2 over 2. So in effect, you're inverting the sign. And remember, we cannot leave the square root of 2 in the denominator, so we multiply it by whatever the radical is. So we have 2 to the square root of 2 over 2. 2 over 2 reduces to 1, so the answer is square root of 2. And then secant would be the same way. That should be a theta there. Secant of theta is going to be the same answer as cosecant, since sine and cosine are the same. And then tangent is 1 over, or cotangent, excuse me, is 1 over tangent, so that's 1 over the value for tangent, so that's 1 over 1, and of course that simplifies into 1. So that's finding all 6 trigonometric ratios. please consult 5-2 if you have any questions.